Hey everyone, in this video I want to talk about what we're going to be dealing with as an intro for inverse functions. So I want to give you a quick intro and some background on what to expect here in the next video. But I do want to talk about today is May 4th when I'm recording this video, and I do want to say that during these troubling times and everything everyone is going through, I do want to wish you that May the 4th be with you. Actually, I'll do like a little 4 right there. In all sincerity, I hope that this video finds you well and that you guys are doing okay, that your family is healthy, and that you're coping with being stuck inside. Hope to see you guys soon, probably when we get back to school next year. All right, let's get started. So, let's first start by talking about how to define an inverse. What is an inverse? A lot of people's immediate reaction or thought is to think of the word opposite. Right? People think that inverse is the opposite of something. So when you say the inverse of 2, what is the opposite of 2? Is it negative 2? Is it 1/2? Is it this right here? I tried to do the inverse of 2, like the flipped version of it. That failed miserably. Like that. Anyway, what is inverse? Mathematically, when we talk about inverse, we know that we're saying we use the inverse of an operation a lot, right? I'll give you an example here. Let's talk about how to solve for a function. Like, let's say that we have an equation that says 2x plus 1 equals 5. When we talk about inverses in mathematics, we talk about doing, at least so far, is the inverse operation. So to solve for x, we need to first get rid of this plus 1. So because we're adding plus 1 here, we're going to do the inverse operation, which means minus 1. So when we do that to both sides of the equation, we're able to cancel them out. And we're left with 2x equals 4. Here we have 2 times x. So the inverse operation of multiplication is division. So we're going to divide both sides by that 2. And then by doing the inverse operation all along, we're able to go from here down to solve for our problem. So we've spoken about inverse operations before in mathematics. The opposite of plus is subtraction, the opposite of multiplying is dividing, and vice versa for those two scenarios. And doing the opposite sort of helps you cancel things out because they are, they could be additive inverse or they could be multiplicative inverses, which really result in a solution of 1, or in this scenario, canceling to 0. Now, the way we're going to talk about inverses is really in an equation format, but there are multiple ways of representing an inverse, right? You can see a function in terms of a graph. You can see a function in form of a table. y1, y2, y3. You can also see this in form of a function. I said that we have an equation that says something like y equals 3x minus 2. Right? So there's multiple representations of this. I'm going to explain to you in all the 3 different forms what does it mean to find the inverse of something that's like a graph, the inverse of a table, and then ultimately this is our main focus, which is going to be the focus for the next video, is how do you find the inverse of an equation? What does it mean to quote-unquote do the opposite, as we like to think about? So let's talk about the definition of inverse. Inverse can be defined as the reflection of a function across the y equals x line. The y equals x has a slope of 1 over 1, and the y-intercept at 0. It is the parent function of a linear function, y equals x. So if we were looking at finding an inverse of a graph, we are looking at finding something that reflects over this line. Doesn't reflect over the x-axis, not over the y-axis, but reflecting over the y equals x line. So let's just start with a point. Let's say that we have a point here at 2, negative 2. If this point is going to be reflected over that line, it's going to have to end up somewhere from this side over to the other side. Some might say from this side to the dark side. Anyway, for this point to land over here, a few things must occur. I'm going to plot this point here. What's going to happen now is now we're dealing with the second quadrant, so we're going to be dealing with the negative x value and a positive y value. What do you notice between these 2 points? Notice how the x value and the y value get flipped. Now, the way I like to think about inverses and reflections is I like to think of this line right here, this y equals x, as a mirror. It's a mirror image of this point. Later we'll talk about the mirror image of a graph, the mirror image of a table, but here the mirror image of a point has to reflect over here. If you put your phone, and if you look at your phone and you go to your snap or you go to your camera and you look at yourself, raise your right hand real quick, look at yourself, stop this real for a second, and look at yourself in your phone. When you raise your right hand, you are raising your right hand, but the person on the other side of that mirror or on the camera, which is also you, or I guess a version of you, don't want to get too much into those details, but some cultures believe that mirrors themselves are where our soul truly exists, right? So we think that we're living in this reality, in this realm, but the mirror or the reflection of us, the pictures, the things that capture our soul is where our soul actually exists. And we, in the real world, are the reflection of that mirror versus the mirror being the reflection of us. Anyway, don't want to get too dark into those kinds of things, but if you look at your right hand, raise your right hand and look at the camera. If you look at the other person across, which is you, what hand are they raising? Your right hand becomes that person's left hand. I want you to think about that for a second, right? Raise your right hand and move it a little bit. Your other self inside the camera is raising the left hand, right? And the mirror app option of things, the right hand becomes the left hand, and if you do the opposite, the left hand then becomes the right hand of the other person. So mirrors behave in that way, where they sort of become the opposite of each other, right? The left becomes right, the right becomes left. If you wink with your right eye, it's the left eye of the other person blinking. And once you take the picture, depending if it's in mirror mode or not, then it'll also do that. It'll flip it, right? It'll look a little opposite. Anyway, so taking that idea, notice how here the x and the y are basically looking at themselves in a mirror. The x is going to become the y value, and the y value is going to become the x. So the rule here is that to find the inverse of really anything, a table, a graph, or an equation, is you want to switch the x and y values so that you get the y comma x. This is what it means in essence for a function to go through an inverse. You want to find the mirror reflection of the points, of the tables, of the graphs, of basically everything. So if we have a table, as an example, let's say we have 1, 2, 3, 5, 6, 7. The inverse of this table, you would want to flip them. So now, if we were to switch the x and y values, the inverse comes out as 2, 1, 5, 3, and 7, 6. If you were to actually graph these points, you would notice how these are now being flipped over this line that we spoke about, the y equals x line. Now, in our next video, we're going to focus on how do you specifically find the reflection of, say, the function we spoke about, y equals 2x minus 3. How do you find the inverse of this function, right? How do we go about reflecting an equation with itself? Well, it comes really down to, and I'll give you a small preview here, it really comes down to this here being the mirror. The equal symbol becomes the mirror. So, if we think of this as a mirror, the y becomes the x, and the x becomes the y. So our very first step actually is going to switch x and y. So now our function turns into x equals 2y minus 3. Now, in order to graph this or to make a table or to solve for this equation, we have to solve for y. When you solve for y, we end up finding the inverse. So, and I'll focus a lot more about this on the next video. Okay, this is what the next video is going to be about. We're going to be talking about how to find the inverse of linear functions. Like this. We're going to talk about how to find the inverse of square root functions, inverse of, let's see, cube root functions, and inverse of like quadratics, for example. All right, guys. Well, stay tuned for the next video where I'll be going to more details of these things. But in general, just think about inverses being or behaving like mirrors. Let me know what you think about that mirror example I gave you about the souls and the pictures capturing your soul, and whether or not you in this, when you think you're living in this realm, are you the reflection of the mirror, or is the mirror the reflection of you? Where is it that your true soul lies or lives? Is it in this world or in the other? All right, guys. Calculator.